Hello, everyone. My name is David Paquette, and I am going to just give another minute here for anyone else to join, then I'll get started. All right. Thank you all for being here today. Again, my name is David Paquette. I'm a product marketing manager with HPE, and today I'm here to talk to you about building cyber resilient data protection for faster cyber recovery. Let me do a little bit of housekeeping here first, make sure everything looks good. All right. Perfect. All right. Let me try to, there we go. So, just getting right off on the challenges that we hear from our customers at HPE, particularly around cyber resilience, cyber recovery, are the first one is evolving threats. The ransomware threats continue to evolve. We continue to see zero-day attacks that no one is prepared for. But we're seeing a lot of older variants of ransomware, in particular, still hitting various organizations, and a lot of times these are done through exploited vulnerabilities or stolen credentials. So social engineering, where they are able to gain access through the various users in the environment. Now, one of the problems that we see too is the number of organizations that are feeling that they should pay the ransom as the easiest way to get their data back. But we're seeing that a lot of those victims of ransomware that do pay the ransom are not able to recover their data, or not all of their data. So they're still losing a good amount of data even with paying the ransom. The speed gap that we see is the slow recovery times, which are all often the contributors to having organizations decide to pay the ransom. And we've seen statistics as well. This one says it often takes over a week to fully recover, and that's the fully recover I think should probably be in quotes there. But what we often see too is that even with good backups in place, organizations are choosing to pay the ransom just to make the recovery process faster for them, rather than having to revert back to their backup solutions where they have their data protected. And finally, one of the biggest challenges is the compliance to all types of new regulations and industry standards that have been coming down around cyber attacks, particularly around ransomware, which is impacting data and downtime for organizations. And this is particularly important because the cost of downtime, particularly from ransomware, and the cost of data loss are very astronomical. This is a stat from ITIC, which was indicating that the average, cost of downtime was around $300,000 for the firms that they surveyed. Some of which, particularly in the upper enterprise, were saying their hourly downtime was between $1 and $5 million. But at all levels, downtime is really just not anything that any company wants to have happen, and there is a definite cost both to financially and to brand reputation for those organizations. Now, the challenges that we see with cyber recovery are a number of different things, and if you see on the right there, that is the NIST governance for cyber attacks, which we always keep on top of. But one of the things that we see in terms of the challenges from our particular customers is the unpredictable attack patterns, where all these different variants of cyber attacks have different ways of infiltrating and actually encrypting data, impacting data within the system. The unpredictable blast radius of an attack. Attacks can range from just having some files and folders affected to having entire sites or multiple sites affected, depending on how far the attack goes. Trying to figure out where a clean recovery point is when you're actually trying to do a recovery. Taking the time to, scan the recovery points and try to determine what is a good recovery point that can be recovered from, and then of course the recovery time to get that recovery point back, and then having to verify it once it's back. And then just the unacceptable data loss and downtime that is associated with these attacks, whether it's days or weeks of data loss or recovery time that organizations have to face to get back online, then these are really just so high, the costs are so high for this data loss and downtime that it is often causing these organizations to go to paying the ransom. Now, I'm going to talk specifically today mainly about HPE Zerto software and HPE Cyber Resilience Vault, but these are part of a broad data protection suite at HPE. A number of these other solutions can also be used in conjunction with HPE Zerto or with each other to do various types of cyber resilience and cyber recovery. I'm going to touch on that a little bit more when I get into talking about the HPE Cyber Resilience Vault. But I just wanted to give you an idea of the number of solutions that are available within our portfolio. Now, HPE Zerto has been a leader in disaster recovery since 2011. Now, it predates HPE itself. We were acquired by HPE. So now we are HPE Zerto software within HPE and a big part of the HPE Cyber Resilience Vault. We are known for having software-only hypervisor-based replication, being able to go across any type of storage or hardware. We're known for providing RPOs of seconds and RTOs of minutes, and for having automation orchestration built in to make it easy to fail over, fail back, and do non-disruptive testing. And I'll get into that more as we go along here. Now, Zerto does a number of different things. HPE Zerto, from all the way from mitigating disasters and neutralizing ransomware and other variations of that, to helping modernize infrastructure, doing hybrid cloud and multi-cloud configurations, and just driving operational efficiency with various types of recovery, from all the way from a single file all the way up to entire sites. So there's a lot of breadth into what HPE Zerto does, but today we're going to focus on the cyber resilience and cyber recovery. Now, HPE Zerto is built on a platform of continuous data protection. I'm going to sort of cover what that means in the next 3 slides, or this slide included in that. And the first aspect of that continuous data protection is our real-time replication. So without using any agents, we replicate all the data changes to virtual machines from your VMware host off to another DR site, or it could be to the cloud as well. We fully support VMware in the cloud. And we do that again in real time. So we're replicating every block change that occurs in real time across the network into your DR site. There's no impact to production or performance. There's no scheduling. There's no snapshots. Again, it's agentless. And along with that, and I'll get into this more later, but there's inline real-time data encryption detection. And again, there's no vendor lock-in in terms of hardware or storage with our solution, because it is a software-only solution. The second main part of the continuous data protection is our unique journaling. So as we are replicating in real time, we are creating recovery checkpoints as often as every few seconds. So we are able to retain those checkpoints every few seconds for up to 30 days. And if you compare that to backup solutions or snapshot solutions, there's a huge gap in our ability to eliminate data loss with being able to recover back to a point just seconds before a disruption hits. Whether that disruption is a cyber attack or any other type of disruption, we can pick a recovery point just seconds before the impact of that attack or that disruption. Again, our detection is tied into this, and I'll get into that a little bit more. The third part of our continuous data protection is our application-centric protection. And this is where, when we do those recovery points every few seconds, what we're doing is a recovery point for a number of virtual machines that you have designated within what we call a virtual protection group. And that virtual protection group can be for a handful of virtual machines. It could be even for one virtual machine, or it could be for hundreds of virtual machines. And we are going to coordinate that recovery point so it is the exact same point in time across all of those different virtual machines. That means if you have complex applications that are within that virtual protection group that have multiple virtual machines creating that application, then we are going to be able to recover those all to the same point in time for consistent recovery. Now, looking at what we do with continuous data protection versus what a backup solution does, particularly for cyber protection, you're going to see a big difference in the amount of time it takes both for the protection and the recovery. And this is just an example of a scenario where 300 terabytes of data are being protected within a data set, and the backups themselves are going to take about 14 hours. Now, this is not backup for a particular storage volume or a particular virtual machine or anything, but the entire backup set across all of the different applications, virtual machines, etc., that are being protected. Once the backup is complete, then the backup is typically replicated off-site. So that's going to take another 4 hours in this particular scenario. And then once the replication is complete, then the backup is typically scanned for any sort of malware or any encryption or anything that may indicate that the data has been compromised. And that scanning process can take a long time depending on the particular technology and what's being scanned for. So combined with all of that, you don't know that you have a good backup in place until about 34 hours after you've started the backup process. With Zerto, it's a lot different. We think of cyber resilience in these three pillars, or three pillars of cyber resilience. First is replicate and detect. Second is isolate and lock. And the third is test and recover. And I'm going to get into what these specifically mean. So first of all, for replicate and detect, we're going to look at the anatomy of an attack. So this is based on the MITRE attack framework. So sort of a simplification of it, but it's really good for illustrating our purpose here. You have your initial access, which is the exploited vulnerability or the stolen credentials, etc. And then you have the command and control. That's where the attacker actually is able to put the malware into the system and connect to it, and now has access to the internal network. Then you have lateral movement, where the attacker will try to move around within the network, try to possibly exploit more credentials, exploit more security access throughout the network, try to move around in order to inflict as much damage as possible when the attack is going to begin. Then you have a phase where the attacker will try to disable any security that they have access to, or backup agents, or any sort of recovery software that exists. They will try to disrupt that, disable that to prevent recovery, and to prevent any security measures from either detecting what they're doing or preventing them from what they're trying to do. And that is what we call the dwell time. That is where the attack has not technically, I guess it's technically started in the sense that an intrusion has happened, but the actual malware package, if you will, has not gone off. The bomb has not gone off. No data has been encrypted yet. Nothing has been deleted. That is all a process by which they are setting up for when the damage is really going to occur. And we see that typically is about 5 to 9 days. It tends to be getting shorter for some ransomware variants, but it's not too long of a process. And there are some that happen very quickly, but this is just an example of we're looking at here. Now we want to focus right now though on after the encryption starts. And this is where we want to determine how fast we can detect if an attack is actually occurring. And that's where our encryption detection comes in. Now we have built-in encryption detection, which I mentioned earlier within our replication stream. So we are replicating all those changes and we're creating those checkpoints, every in this case it's 5 to 15 seconds, typically under about 10 seconds, so single digits. But so we're creating those checkpoints, we're replicating everything in real time. Now, at the same time that we're replicating, we're looking at all of those blocks of data as they're passing through, and we are trying to see if they are encrypted, and if they are, we're trying to look for anomalous behavior in the encryption. So something out of the ordinary that may indicate that a ransomware attack is going on. If we detect that, then we will flag the checkpoints. We will also send an alert up, of course, alerting you that something is going on, but we will tag the checkpoints so that when you want to go later and recover, you can see approximately when the attack may have begun. So you can choose a checkpoint just a few seconds before the attack began when the anomalous encryption was detected, and then you can recover to a clean checkpoint prior to that by looking at all these tag checkpoints within the journal. Now, we've also recently done an integration with CrowdStrike Falcon, and this really expands the detection capabilities far beyond what just detecting the encryption after the attack. CrowdStrike is one of the leading cybersecurity solutions on the market, and they have many different types of detection, from intrusion detection all the way down to malware detection and detecting when an attack may be taking place based on anomalous behavior. And they really have a wide breadth of types of detection that we can tap into with this integration. So with this integration, like our encryption detection, we are using this to tag these recovery checkpoints when something is detected by CrowdStrike. So, as CrowdStrike Falcon detects something going on, whether it's ransomware or some other factor indicating an attack is happening, we can tag these checkpoints, and then as you are going to recover from the attack, again, you will have indicators of when the attack may have begun based on the tag checkpoints. So it really gives more of a breadth of detection capabilities and more of an insight into possibly what the blast radius is, when the attack actually began, making it much quicker for you to respond and to determine what a good recovery point is and what needs to be recovered. Okay, going back to the MITRE framework, now we want to focus on sort of like the middle there in the dwell time, where the attacker is moving around laterally within the network. And this is where we get into our isolate and lock phase, because this is where we want to make sure that that attacker, as they are moving around in the network, particularly before they have the ability to start trying to disrupt any sort of security or backup services or any sort of recovery services, that there is something we can do to stop them. So in this case, there are a couple different methods that we have now. Just within regular HPE Zerto software, there is the ability to create what we call extended journal copies. So creating an extended journal copy is sort of a point in time out of the journal that you want to designate as a point that you might want to recover from if all else fails. So think of it more in a sense as a traditional backup, a copy of data. And then that copy of the data can be stored on local storage. It can be stored on remote storage, or it can be stored on cloud storage. Any of those that you choose from. Often it's done on local storage just for a faster recovery, but it can be done any of those places. And then once that data is stored, it can be made immutable, so that the attackers do not have the ability to delete or modify or encrypt that immutable data copy. So if all else fails, you can always revert to your extended journal copy to recover your data. So that is the ability that we use as well with our Zerto Cloud Vault that is offered by some of our managed service provider partners. Now, we have the option of going to the HPE Cyber Resilience Vault as well, and I'm going to get into a lot more into what the Cyber Resilience Vault really means. And this is very much the next level of protection. Might call it the highest level of protection that you could achieve. And you'll see what I mean when I show you how it's built. But really, this goes far beyond just doing immutability and sort of isolating something off in another storage area. It really involves a lot of air gapping and zero trust principles built around the vault for being able to give you a fast recovery in a worst case scenario. Now, the test and recover part of our 3 pillars, I'm just going to touch on it here, and then I'm going to get back to it a little later as we talk more about the Cyber Resilience Vault. But Zerto gives you the ability to test non-disruptively. So there's no impact to production, to protection, to recovery, and you can test anytime with no maintenance windows. So you can really perform a test recovery, anytime you want. And even during the midst of a test recovery, you can still revert back into a full recovery without any impact to your protection or your ability to recover. It's great for supporting compliance because we do an automatic test report and allows you to test as often as you like. So you can really test often and with reporting built in to give you the ability to test at many different levels of severity or for those cyber attack scenarios. And particularly for rapid cyber recovery, um, our recovery capabilities give you the ability to recover very quickly. I'll get into that a little bit more when I'm talking about the Cyber Resilience Vault. But the recovery is orchestrated. It can be very granular, and you can validate all of the recovery data prior to moving it back into production. Cyber vaults, like the HPE Cyber Resilience Vault, are becoming increasingly mandated for certain industries, certain levels of enterprise organizations that have something beyond what a typical organization might have in terms of requirements for their data. We're seeing a lot of new regulations, legislation, and insurance company requirements for cyber vaults in order to protect data against cyber attacks. One of the key points of the cyber vault is to protect the data that you are already using as your data protection. So whether it's your backups or any other sort of recovery data, you need to protect that sort of at another level to keep it away from attackers and prevent them from being able to access it to prevent recovery. And again, this can be considered an option of last resort when all else fails. And I'll talk a little bit more about that when I talk about the vault recovery. So in a legacy vault architecture, and you still see this in a lot of vaults that still exist today, you have your production environment, of course, and these are typically based on backup solutions. And the backup is being sent into a vault environment, which is basically just an environment like a typical backup environment, but that has the ability to make the data immutable and potentially have a secondary air gapping for that data within the backup vault. There are a number of problems with these legacy vault architectures, first of which being they typically have a management layer that goes between the production and backup, which can be exploited. This is how the backups can be manipulated by the attackers to make recovery more difficult, or if not impossible. You also can see that they're in a lot of these solutions, they use purpose-built backup appliances that are going to be slower than your traditional performance storage. The whole cheap and deep methodology of backup storage. They typically use backup agents, which can also be exploited by attackers. So if they have the ability to access those backup agents, they can disrupt the ability to protect the data. The slow post-processing, which we kind of talked about in the whole backup recovery process, and then lengthy backup windows. So That means that with those backup windows, it's going to increase your recovery point objective, or the amount of data that will be lost when you try to go to recover data. And then again, when you're storing that data within the vault, again, that's also often cheap and deep storage, whether it's purpose-built or cloud storage. And that is typically going to be slower than production grade for recovery purposes. And finally, if you are going offsite, particularly to the cloud, there can be internet issues which can disrupt your backups. Now, this is a high-level view of the cyber resilience vault. I want to get into this. I'm going to get into it on the next slide much deeper, but I just wanted to point out that it is built around HPE technologies, HPE hardware and software, networking included. And the point of all of this is to have basically like another layer of protection within the vault. So it's not just a bucket for putting your backups in and making them immutable. There's actually physical air gapping involved. There is a production grade environment which to recover. So let me show you a little bit more about what that looks like. So starting with the production environment, this is pretty typical, right? You have your VMware vCenter and your virtual machines. The Zerto components here are the Zerto Virtual Manager, which is the brains of the operation, and then virtual replication appliances, which are handling the actual replication on the hosts. The first part of the vault is what we call the landing zone. Landing zone is what you would think of sort of as a typical DR site or backup site. So again, this is going to be another vCenter environment, and we're going to be replicating directly into this. So we're going to create replicas of all the virtual machines that are being protected into the vault, and all of that is going to be residing on HPE ProLiant compute servers and HPE Alletra storage devices underneath it, B10000s more specifically. And so that's going to include the replicas of the virtual machines and the journals for those virtual machines. Now, the other part of the vault is what we call, that's more animations built in here. So again, this is using the typical Zerto solution that I already explained to you. So it has the encrypted replication going into the vault, the landing area, and it has the real-time encryption detection built in. And you can also incorporate the CrowdStrike Falcon into this as well, if you would like. Now, the other part of the vault is the vault, what we call the vault zone, and that is also built identically to the landing zone in terms of the hardware configuration with the servers and the storage. And it's built with Aruba networking, and that is going to be connected to the landing zone by a dedicated storage connection between the two Alletra storage devices. So this is where you have the second layer of protection built in. So what's happening here is that there are periodic snapshots being taken on the HPE Alletra storage device and sent across into the vault zone. Now, there is that dedicated storage network. That storage network is really only being connected between those two devices specifically, and it's being managed from within the vault zone. So it does not really appear on anyone's network outside of the vault zone. It's fully managed from within the vault zone. So it's basically pulling the snapshots. It's from the landing zone. So there is no management capability to disrupt that from the outside. There's a full air gap. It controls the actual connection. So it only opens up the network connection when it wants to pull those snapshots across. And it's going to pull those snapshots every 4 hours. And then finally, there is immutability built in, as well as a number of zero trust principles built into the vault zone and the landing zone within the hardware setup to protect that data, even against someone gaining access to it directly within the data center itself. Now, this is typically going to be located at the data center alongside your production environment. It doesn't have to be. It can be remote. It could be at another site. It could be hosted by an MSP, for example. But a lot of organizations or our customers like to keep it close to their production environment because it is specifically being used to recover from cyber attacks, not other types of natural disasters. And so they can recover more quickly being in the same location. So those two areas, the landing zone and the vault zone, are what make up what we call the HPE Cyber Resilience Vault, which is what we refer to as a validated reference architecture, including all of these various components, that some of which I mentioned earlier in our data protection suite. So this is the Cyber Resilience Vault with a combination of HPE Zerto software and the HPE Alletra storage data protection built in, giving you multiple layers of protection. But what does recovery look like? This is where it gets really interesting. So when you want to do a recovery, the first scenario is that you've been impacted by a ransomware attack in your production environment, and your production environment is now compromised and you need to recover. Well, the first thing that you can do is, if your actual landing zone has not been compromised, in other words, with the lateral movement of the attacker, they have not gotten into the landing zone itself and compromised, Zerto or any of the VMware resources or storage within the landing zone, which is on the same network as the production, then you can just recover from the landing zone. So this would be just like recovering from Zerto and other scenarios, where you can recover very quickly within a matter of minutes and have your data back up in a good state. Now, when we recover the data using Zerto in this way, we recover it first into an isolated network environment. So what we might call like a network bubble. That way the attacker does not have access to that isolated network environment. So you can start recovering the data into the isolated network. And in that isolated network, you can validate to make sure that that is the data that you indeed want to recover back into production. Then you can recover it, wherever you would like, to another set of hardware, another site, wherever makes sense for that particular scenario. So, the first thing you would do is just select the virtual machines that you want to recover. I didn't really mention this earlier, but you can, choose anywhere from individual virtual machines, even individual files and folders, all the way up to entire sites worth of data. Now, because of the way we do our virtual protection groups, that will give you some insight as to what's, with our detection capabilities, it'll give you some insight as to which virtual protection groups were affected and which ones you need to recover. That, of course, is all part of the forensics process as you were trying to recover, but you can quickly sort of ascertain from which virtual protection groups were impacted, which ones need to be recovered. So you would select the checkpoint that you want to recover from, and because of the encryption detection, that will often indicate, what a good clean checkpoint is. And then you can non-disruptively test, as I said. So you can do this as a test process, or you can do it as a recovery process. It's more or less the same process. The only difference is whether or not you can easily undo it, or whether you're trying to actually recover things into production. Either way, it's a very, very similar process, and this is going to allow you to get that data back up very quickly. And then all of your infected workloads, the data pre-infection can be recovered. Now, if the landing zone is compromised, then you have to go into the process of recovering from the vault zone. And this is a sort of a multi-step process, where the first thing we do is we mount the VMFS from the immutable snapshot that was taken. So that's going to allow you to, and in this case, we're protecting everything within that storage device, including all of VMware, all of Zerto, etc. So it's going to allow you to start up vCenter and Zerto within that environment, running on the host just as if it was in the original landing zone environment. So it's going to more or less look identical to it. And then it's going to give you the ability to recover, just as I described before, from Zerto into that vault zone, or from the vault zone somewhere else. But you can first recover into the vault zone, and that's why we put the production grade hardware in there, whether it's the storage hardware or the computer hardware, so you can actually be running those workloads within the Proliant and Alletra storage and the Aruba networking, in fact, and give you that production grade environment, so you can actually run those workloads, validate them, make sure they are running as as you would like them to be without anything being affected by malware before you recover them back into production. And that just gives you a much faster ability to respond to the ransomware attack and to recover that data within the vault zone, so you can quickly begin forensics and remediation of that data. So that's going to reduce your recovery time down to a number of hours rather than days or weeks with other solutions. So just to sort of summarize, the things that HPE Zerto software brings to the table: the continuous data protection that I mentioned, that operational efficiency, really having to do with the built-in orchestration and automation for the testing, and the ability to do integrations with our API first methodology, and the ability to do this not just for on-premises environments, but across on-premises and cloud, hybrid cloud, etc. And just the simplicity at an enterprise scale. You can do this whether it's dozens of virtual machines or thousands of virtual machines. Any number of virtual machines can be protected using HPE Zerto, and particularly with HPE hardware. So with that, I'm going to wrap it up. Here's a few resources that you can look at. Just go to HPE Zerto software website. I know these are links on here. I should have put QR codes on here. I'm sorry I didn't do that. But if you go to Zerto on HPE, I think it's hpe.com/Zerto, you can find the ability to take a test drive. So it's a hands-on lab that you can do. So you can try Zerto out for yourself and actually simulate a ransomware attack and recover from that. You can request a free trial, or you can look at the rest of our data protection products from HPE. So with that, I'm going to go to the Q&A. I believe my lead guitarist, Andrew Silva, has been answering some of those questions. Andrew, are you there? I'm going to invite him from the backstage if I can. Hey, Andrew, are you here?
I'm here, David.
Great. So I've been talking, so I haven't really had a chance to look at the questions, but you have. So what have we got here?
Yeah, so we had a couple questions that came in. We had a question come in on how Zerto is licensed, right? So it's going to be on a per protected VM licensing basis. So that was one question that we had come in.
That's good.
Another question that we had, and this was related to the cyber resilience vault, and I responded to it in the chat, but just so everybody can hear, the question was, if primary storage was infected by ransomware, then the replica copy and vault copy would be infected. How can we provide verification to be safe in the vault? So that's a very good question, and I think you might have hit on it as you were kind of going through those recovery workflows. But just to lay this out, there's a few different mechanisms where both Zerto and the storage array that's in part of the vault on the Electra B10000, they both have encryption detection, right? So the thought would be, hey, you have your vault set up, it's replicating data into the vault, it's immutable. And then if you have a ransomware attack occur, you would be notified of, in the ideal situation, that, hey, an encryption event is happening that would either be detected by Zerto. We would flag a checkpoint in the Zerto journal, so you know exactly what point in time that encryption activity started. And then you'd also have another checkpoint in that Zerto journal when normal activity, when last normal activity was detected, right? So
Right.
that's one way to kind of identify the blast radius. And then you also have that same type of technology built in on the Electra B10000 as well. And that can also give you, another layer of detection. So you kind of know when the actual detonation of ransomware occurred. So ideally, right, what would happen is, okay, well, we detected it at a specific point in time. We would then go to our vault zone and then recover back to a prior point. So the thought would be, you'd already have data that has been replicated and secured in the vault, and you would leverage those those copies to recover in that same recovery workflow that David had, right? So there is, you know, so that's really how it would work. That would be one of the logical workflows to follow, is leveraging those built-in kind of cyber resilience capabilities that are in the product to then establish when that detonation and like understand kind of that blast radius, and then also that point in time in which that payload was deployed.
Yeah, that's great, Andrew. Thanks for answering that. I'll also add in that I didn't really mention this, but when you go to recover from with HPE Zerto, you can you don't it's not a one and done situation. You're not just picking a recovery point and then that's what you're going to get. If you recover that data, and this is why we do this in isolation first, is you can then validate that data. And if it's not the data that you wanted, if there is something compromised about the data that you recovered, you can go back and recover. You can undo that recovery and you can go back and recover from a different checkpoint, making sure you get the one that's correct prior to moving that data back into production. So, even if you did not choose the correct recovery point the first time, or even the second time, that's all right. You can still recover from, the point in time that it makes the best sense for you. That's the clean recovery point, and that's may vary depending on the type of attack and how much damage was done over the course of the attack prior to recovery.
Yeah, and I think those were the only questions that we really had in the chat. So
Okay. Yeah. One
yeah.
question that we often get, which I'll just throw out there because I probably could have mentioned this, but does the Cyber Resilience Vault have to be built on HPE hardware? And the answer to that is yes, it does, partly because we have to validate that architecture, and we can really only do that very successfully with our own HPE hardware. But more importantly, the HPE hardware that we're using, particularly the Electra storage, provides a lot of capabilities that are crucial to being able to recover that data to a clean checkpoint and having that encryption detection built in at a second layer beyond HPE Zerto. So there are a lot of benefits to having the vault built around that particular hardware, particularly our ability to validate it to make sure it's going to work for you.
Yeah, and beyond validation, just to add a little bit more is, it's supported by HPE, right? So I
That's
mean,
right.
that's a big thing, right? It's if you're actually having to go through recovery workflows and you're trying to build your own vault and something goes wrong in those recovery workflows, or something's not powering on as expected, you're kind of you're stuck figuring that out on your own. And to David's point, because this is a validated architecture on all HPE hardware and software, right? We have the right support SLAs to be able to provide assistance if you do run into some of those recovery workflow issues or uh, things of that nature.
All right. Well, hey, Andrew, thank you so much for helping out by answering the questions. And I think that's all the time we have. So we're going to go ahead and close it out today. Thank you.
Thanks.